So when you think about the global powerhouses in technology, your mind probably jumps to a few key places: Silicon Valley in the United States, maybe Shenzhen in China, or even Taiwan, home to giants like TSMC. But what if I told you that one of the most critical players in the entire AI and semiconductor race is a small, flat country in Europe, better known for its tulips and windmills? That's right. I'm talking about the Netherlands. It's a place you might not immediately associate with cutting-edge chip manufacturing, but it's quietly become absolutely indispensable to the entire industry. At the heart of this story is one company, ASML. Now, this isn't just any tech company. They've built something that no one else in the world can replicate. A machine that is fundamental to creating the most advanced chips that power everything from your smartphone to the supercomputers running AI models. It's a monopoly born from decades of insane engineering and physics, and it's given the Netherlands a unique and powerful position on the world stage. It's one of those, if you know situations in tech, but it's becoming more and more important for everyone to understand. So, how did this happen? How did a country of just 17 million people become the gatekeeper for the future of computing? It's not just about one company, as incredible as ASML is. It's a much bigger story involving a complete ecosystem, strategic government planning, world-class education, and some serious geopolitical chess. Today, we're going to break it all down. These are the 6 key reasons why the Netherlands dominates the AI chip landscape. Let's get into it. Alright, so first things first, we have to talk about ASML and its insane technological monopoly. At the core of every advanced chip, the ones from Apple, Nvidia, Intel, is a process called lithography. Think of it like a super advanced form of photography, where you're printing unimaginably small patterns onto a silicon wafer. For decades, the industry used deep ultraviolet, or DUV light. But as transistors needed to get smaller and smaller, we hit a wall. To get past it, you needed a new kind of light, with a much shorter wavelength. This is where ASML comes in with extreme ultraviolet, or EUV lithography. This technology is, and I don't say this lightly, a modern marvel of engineering. To create this light, the machine fires a high-powered laser at a tiny droplet of molten tin, vaporizing it into plasma 50,000 times a second, which then emits EUV light. This all happens inside a massive vacuum chamber because EUV light is absorbed by literally everything, including air. The mirrors used to direct this light are the flattest surfaces ever created by humans. It's ridiculously complex. And here's the kicker: ASML is the only company in the world that has successfully commercialized this technology. They spent decades and billions of dollars on research and development, and now they have a complete monopoly. A single EUV machine costs around $200 million, weighs 180 tons, and requires multiple cargo planes to ship. Competitors like Nikon and Canon are years, if not decades, behind. This isn't just a lead, it's a moat so wide that no one else can even see the other side. Every single company making leading-edge chips needs ASML, period. Having a monopoly like ASML is obviously a huge advantage, but what makes the Netherlands truly powerful is that ASML isn't operating in a vacuum. The country is one of only 3 in the world, along with the United States and Japan, that has a complete semiconductor value chain. That means they have companies and expertise covering nearly every single step of the process, from the initial research and design all the way to packaging and testing the final product. It's what makes the ecosystem so resilient and self-sufficient. So while ASML handles the most critical lithography step, you have other Dutch powerhouses playing key roles. Take a company like NXP Semiconductors, a spin-off from Philips, which is a massive player in automotive and secure connectivity chips. They design and manufacture a huge range of semiconductors that are essential for cars, payment systems, and the Internet of Things. Then you have BE Semiconductor Industries, or BSI, which specializes in the back-end assembly equipment, the crucial final steps of packaging and connecting the chips. This creates a powerful feedback loop. You have research institutions, design firms, equipment manufacturers, and chip makers all located within a relatively small geographic area. They can collaborate easily, share knowledge, and push each other forward. It means that when a new challenge arises in chip manufacturing, the expertise to solve it is often just down the road. This complete end-to-end full-stack approach is a massive strategic advantage that goes way beyond just having one superstar company. So why did all this incredible tech talent and infrastructure concentrate in the Netherlands? A huge part of the answer lies in a concept they call the quadruple helix model of innovation. It's a fancy term, but the idea is simple and powerful. You get industry, government, research institutions, and the public all working together, tightly integrated. It's not just a loose partnership, it's a deeply embedded culture of collaboration. And nowhere is this more visible than in the Brainport-Eindhoven region. Brainport is basically the Silicon Valley of the Netherlands. It's one of the smartest regions in the world, consistently ranking high for research and development investment and patent applications per capita. This is where ASML, NXP, and hundreds of other tech startups and suppliers are headquartered. The ecosystem is fueled by world-class universities, most notably the Eindhoven University of Technology and Delft University of Technology. These aren't just academic institutions, they are deeply integrated with the industry, funneling top-tier engineering talent directly into these companies. This creates a self-reinforcing cycle. The companies provide real-world problems and funding for research. The universities produce graduates with the exact skills the industry needs, and the government facilitates this collaboration with smart policies and infrastructure investment. It's a system designed to foster deep tech innovation. Young engineers and entrepreneurs are surrounded by mentors, venture capital, and cutting-edge facilities. It's this dense, collaborative environment that allows for the kind of long-term, high-risk research and development that created EUV lithography in the first place. A thriving innovation ecosystem doesn't just happen by accident. While the companies and universities provide the brainpower, strategic government support has been the crucial catalyst. The Dutch government recognized early on that the semiconductor industry was not just an economic engine, but a matter of national and European strategic importance. They've been willing to make significant, long-term investments to protect and grow this asset, treating it with the seriousness it deserves. A prime example of this is Project Beethoven. That's the code name for a multi-billion euro government plan designed specifically to ensure that ASML and the surrounding ecosystem not only stay but expand their operations within the Netherlands. This isn't just about throwing money at a company, it's about investing in the entire environment, improving infrastructure, funding education to create a larger talent pool, and cutting red tape to make it easier for companies to grow. It was a direct response to concerns that ASML might move operations elsewhere. Beyond that, the Netherlands is a key player in broader European initiatives. They are heavily involved in the European Chips Act, a €43 billion plan to double the EU's share of the global chip market. At the national level, programs like ChipNL are investing hundreds of millions to stimulate research and development in next-generation chip technologies. This proactive, strategic, and well-funded government support sends a clear message to the world. The Netherlands is all in on semiconductors, and they are playing to win for decades to come. Okay, so a technological monopoly, a full value chain, a great innovation ecosystem, and government support, that's a powerful combination. But it also creates the fifth and perhaps most fascinating reason for Dutch dominance: geopolitical influence. In a world increasingly defined by a tech Cold War between the US and China, controlling a critical choke point in the supply chain is like holding the ultimate trump card, and ASML's EUV technology is arguably the single most important choke point in all of tech. Think about it. Every country with ambitions in advanced computing, AI, and defense needs the most powerful chips. And to make those chips, they need ASML's machines. This gives the Dutch government, and by extension its Western allies, a huge amount of leverage. The United States has leaned heavily on the Netherlands to restrict the sale of advanced EUV and even some older DUV lithography equipment to China, effectively kneecapping China's ability to produce its own leading-edge semiconductors. This puts the Netherlands in a delicate but powerful position. They have to balance their own economic interests. China is a huge market after all, with the security concerns of their allies, particularly the US. The decisions made in The Hague about export licenses for ASML machines have direct and massive consequences for the global balance of power. It's a level of influence that a country of its size would not normally have, and it all stems from mastering the physics of light inside a giant, super expensive box. Finally, let's talk about the bottom line, the massive economic impact. This entire ecosystem isn't just a matter of national pride or geopolitical strategy. It's an incredibly powerful economic engine that fuels the entire country. The numbers are pretty staggering. The Dutch semiconductor industry generates tens of billions of euros in revenue each year, with ASML alone posting revenues of over 27 billion euros in 2023. This isn't just a niche sector, it's a foundational pillar of the modern Dutch economy. This economic strength creates a virtuous cycle. The high revenues and profits generated by companies like ASML, NXP, and BSI are reinvested back into research and development, fueling the next wave of innovation. It also supports a vast network of smaller suppliers, service providers, and startups, creating tens of thousands of high-paying, high-skill jobs. This concentration of employment and wealth, particularly in the Brainport region, drives up living standards and attracts even more talent from around the world. When your tech sector is this successful, it has ripple effects everywhere. The tax revenue helps fund public services, the demand for housing and services boosts local economies, and the reputation for innovation makes the country an attractive place for other foreign investment. This economic bedrock provides the stability and resources necessary to keep taking big risks and making the long-term bets required to stay at the cutting edge. The economic impact isn't just a result of their success, it's a key ingredient that allows that success to continue. So, there you have it. The Netherlands' position as a chip superpower isn't an accident, and it's not just about one legendary company. While ASML's EUV monopoly is the crown jewel, their dominance is built on a much broader and more resilient foundation. It's a carefully constructed system of a complete value chain, a deep-rooted culture of collaboration in the Brainport region, world-class education producing top-tier talent, and smart strategic government policy that ties it all together. It's a masterclass in how to build a high-tech ecosystem from the ground up. But of course, staying on top is never guaranteed. There are real risks. The heavy reliance on a single company, ASML, creates a potential single point of failure. What if there's a major disruption there? At the same time, the whole world is waking up to the strategic importance of semiconductors. The US, China, and other nations are pouring hundreds of billions of dollars into their own domestic chip industries, trying to replicate the kind of ecosystem the Dutch have perfected. The global race to catch up is on, and it's more intense than ever. The big question is whether this unique combination of factors that got the Netherlands to this point is strong enough to keep them there for the next decade. Can they fend off the massive global competition and maintain their lead? It's a fascinating story to watch unfold. I'd love to know what you guys think. Drop a comment down below. Can the Netherlands hold its position, or will the rest of the world close the gap? Thanks for watching, and I'll catch you in the next one.